Hey everyone, CJ here, your local friendly technology addict, and in tonight's episode, let's see if I can get through this in less than 30 takes. So, back in the 1780s, 1790s, early 1800s, if memory serves, it's been a while since I've done this research. This gentleman by the name of Alessandro Volta, in seeing what some of his contemporaries were doing with frog legs and hooks of different metals, decided to do an experiment of his own. And what he did was take discs of two different metals. I don't remember exactly what metals they were. I think they were bronze and zinc. It might have been copper and zinc. I just don't remember. But you can look it up. You can look up the Voltaic Pile, Voltaicpile. And a voltaic pile of discs is, for all intents and purposes, a battery cell. Actually, a battery. Now, a cell is a single pairing of two different metals with an electrolyte between them. And a battery is any combination of cells together. Now, what we're going to use for an electrolyte in this experiment is good old pickle juice. And the reason for that is because once you get rid of the fresh cucumbers, you're left with water, salt, and distilled vinegar. Well, distilled vinegar is acetic acid, so that's going to help. And the fact that we've got salt in there is going to help too. It's going to make maybe not the best electrolyte in the world, but it's certainly going to work for these purposes. And for the discs, I've got two different United States coins. One is the United States 5-cent piece, commonly called the nickel by Americans. And you'll notice that this one's been roughed up a little bit with a piece of sandpaper. And we also have the United States 1-cent piece, commonly called the penny by Americans, and similarly roughed up. Now, the reason I roughed it up is because there's always some level of corrosion, some level of oxidation on any country's currency. And that layer of oxidation will make it very difficult to obtain the results that we're looking for. So I roughed them up a little bit. I also have with me a voltmeter, which I don't know how to prove is not attached to anything untoward. This is all we've got. It's just this little meter. Cables back around. All right. And I currently have it set for 2 volts DC range, which is to say that once it goes over 2 volts, it'll read over voltage. And I would have to go up to the next scale, which is 20 volts DC. I don't think we're going to get that high, but we will definitely see enough that we can do something with this. Now, if I just do that, okay, you can see there's no voltage. Now, if I bring the coins together, still no voltage. And there's not going to be. Until I set an electrolyte between them. Now, what I have here is a simple, everyday dinner napkin, just a little paper napkin that I have folded again, folded again, folded again, and that is the size of squares I've cut out of this napkin. And then those squares I've separated into piles that were roughly evenly distributed sheets, okay, and there were 8 piles, not that that makes that much of a difference. But those piles, okay, I would then fold again, and then dip in this little tray here that I've got some pickle juice in. Now, that penny and nickel have been sitting there. The nickel should be a positive, the penny should be a negative. And look at that, half a volt, a little over half a volt. All right, well, let me do this experiment again. Let's do it right here. Now I'm just going to squeeze out the excess. I don't really need that much. We'll set it right on top here. And we'll set the penny on top of that. And we'll do the same thing. Nickel is the positive. Oh, wait, no. Nickel is a negative? No, no. Nickel should be the positive. Yeah, nickel's a positive. Half a volt, actually 0.65 on that one. So this one here is reading a negative voltage. I don't understand why that is. Okay, so this one's out. And I'll just set them aside, and we'll try this one. I do not understand. That may be maybe some corrosion I didn't get completely removed or some other factor. I really don't know. And this one's only 0.08. How about this? Let me add a second layer. Not really adding a layer, just making it thicker, honestly. And see what happens there. Okay, now we're up to 1/10 of a volt, which is still kind of disconcerting that this one's making 0.7 almost, and climbing. And this one's 0.18, 0.19, 0.2. So I'm thinking that as the pickle juice equalizes between the two, it probably does a little bit better. Now I've got a proper battery. I have 2 cells in series to produce a single battery of cells. We're up to almost 0.8. Okay, 0.8, 0.81. Let me stack some more on top. We'll just see how far we can go with this, right? My hope is that I can get enough to light up an LED. We've broken a volt. That's not enough to light up an LED, unfortunately. Now we're already up to 7.5 minutes. I am 3/4 of the way through the video, and I still have not done what I've set out to do. Other than, well, yeah, I kind of have. So part of what I set out to do is demonstrate that you can make a battery at home. It's not a very good battery. It's not going to be a battery that'll, you know, make you a ton of money or free up your AC bill. 1.3 volts. Let me add the rest of them. All right, I've added one more cell. And we are now up to the same level as a brand new alkaline cell. 1.592. And move that out of the way. This one is producing 1.9 and rising. So let me get my LED and see what we can do. Okay, so I'm up to 8.5 minutes. I'm trying to save some time here by pausing the video. And we're up to 2.4, 2.5. I don't think that's going to be enough because most, if not all, of my LEDs have a minimum 2.7 volt forward voltage. But I think I've got it. I'm going to have to turn my light out, or at least aim it somewhere else because it's making it hard to see. But ever so barely you can see it light up. Now, of course, there's not enough there to, you know, do anything productive with, but you can see with just that battery there that you can produce a voltage. And depending on the chemicals and metals that are used, you can maybe even get enough voltage or current out of it to do something useful. So think about what you can do with that for a science fair experiment and how you can improve it. And let me know in the comments how you do. Until then, take care.